On to Chapter 6. So first deals with position, velocity, and acceleration. And so we have, if you have your position function, position, so the derivative of position gives velocity, and then the derivative of velocity gives acceleration. And so then, if you do the other way around, if you integrate acceleration, you get velocity. And if you integrate velocity, you get position. So, for example, an example of this would be given that the position function s is given by 4.9t squared 16t minus 20. So this tells me my position of my object. And then if we do ds dt, this will be 9.8t plus 16, and this would be my velocity. And so we have v equals 9.8t plus 16, and then if we do dv dt, we get 9.8, and this is the acceleration. So if we go the other way around, so now we start the other way. So now given that the acceleration, that a is 9.8, and we integrate 9.8 with respect to t, and then we get v is going to equal 9.8t plus c, whatever that is. So this is my velocity. And then if we were to integrate this one, we would now get 9.8 t squared over 2 plus c times t plus c1. And this would be the position function. So this is going to be 4.9t squared plus ct plus c1. And that'd be my position. Right? So let's do an example of how this would work. So let's say we are given that a sub t equals minus 32, v naught is 70, and s naught is 10. So if we integrate negative 32 dt, we get velocity equals minus 32t plus c. Right? But we now know when t is 0, the velocity is 70, so we can plug that in. So 70 equals minus 32 times 0 plus c. So C is 70. Okay. So my velocity is minus 32t plus 70. And so now if I integrate this, again with respect to t, get a minus 32t squared over 2 plus 70 times t plus c. So this is going to be my position. And so this will be a minus 16t squared, 70t plus c. But then again, we were told that S0 is 10. So we have 10 equals minus 16 times 0 squared plus 70 times 0 plus c. So c is 10. And so position was given by minus 16t squared plus 70t plus 10. And we're done, right? So then some of the other things this chapter deals with is finding the area, the region between two curves. So area between two curves. So for example, you have one like this, that f of x is equal to 5 minus x squared, and g of x is equal to x squared minus 3. And we want to know, what do those look like? So let's first draw a graph roughly. And so if I graph this, this one, the f of x curve is going something like this. So this is my f of x. And then my g of x curve is going something like this. And what we want to know is what is this area in between the two curves. So the first thing we need to know is, well, where are those intersection points? So to do that, we take the two equations and we're going to set them equal to each other. And so we're going to add the 3, add the 3, add the x squared, add the x squared. And so we get 8 equals 2x squared. And then we can divide by 2. So x squared is equal to 4. So x is going to be plus or minus 2. So those are my endpoints. So now to do our integration, we're going to find this area. We're going to go integrate from minus 2 to positive 2. And then it's sort of the black curve that's keeping the lid on the area. So we're going to put that one first. Minus this one. And then we can do the little bit of math part before we actually do our integration. So we can sort of simplify this. So 5 minus a minus 3, this is going to be 8. Minus x squared minus another x squared will be minus 2x squared. And so now we can integrate. So this is going to be 8x minus 2x cubed over 3, evaluated from negative 2 to positive 2. Well, then it's a matter of plugging in the numbers, and we see what we would get. So this would be 8 times 2 minus 2 times 2 cubed over 3 minus 8 times a negative 2 minus 2 times negative 2 cubed over 3. Okay. And so when you number crunch this all out, you would end up at 64 over 3 is the area in between. Right? Well, we can integrate with respect to x. We can also do it with respect to y. So if we have one that looks like this, x equals y squared minus 3y plus 12. And then my other equation was x equals minus 2y squared minus 6y plus 30. So again, let's look at a picture of what is going on here. And so black one first. So my black curve is going something like this. And then my other curve is going something like that, right? In terms of a picture. Right? Well, again, we need to know what we need to integrate from where to where. And so again, we take our equations and we set them equal to each other. So y squared minus 3y plus 12 equals minus 2y squared minus 6y plus 30. And it is a quadratic, so we want to set equal to 0. So we're going to add 2y squared, add 6y, subtract 30, add 2y squared, add 6y, and subtract 30. And so we end up with a 3y squared plus 3y minus 18 equals 0. Well, then I could factor a 3 out. So y squared plus y minus 6 equals 0. And then this could be factored. So y plus 3, y minus 2. So either the y plus 3 was equal to 0, or the y minus 2 would equal to 0. Solve each one of those. So here I subtract 3. Over on this side we would do the adding of 2. And we get our two numbers. So we're going to go from negative 3 to 2. Okay. So now we're going to do our integral. And so we're going to integrate from minus 3 to 2. And it's going to be the minus 2y squared minus 6y plus 30 minus the y squared minus 3y plus 12, integrating with respect to y. And again, we can do the math part and simplify this a bit. So this is a minus 3y squared minus 3y plus 18. And we integrate this, we will have a minus y cubed minus 3y squared over 2 plus 18y evaluated from negative 3 to 2. And if you number crunch this all out, you would end up with 125 over 2. So we found the combined area between the two curves, and so the next section deals with finding volume. And so the chapter deals with several different methods of doing this. So volume by slicing. So you get V equals the integral A to B, A of X, T of X. But then a couple other particular methods is the disk. Try that again. Right. And so the disk and washer method. And with respect to the x-axis. So first off, v equals integral a to b pi f of x squared ds. And so this is the disk method. And then v equals a to b pi f of x squared minus g of x squared. And this is the washer method. Right? So let's look at an example in terms of these. So let's say we have this. So y equals e to the minus x, and then y equals 0, x equals 0, and x equals the natural log of 4. So what are we looking at here? Right? And so my curve is going something like this. So my y equals e to the minus x, and then x equals ln 4 would be this going here. So it'll be that right there. And so we want to know in terms of this. So basically we're taking that and we're spinning it around the x-axis. Right? So my volume, V, is going to be given by 0 to the natural log of 4 pi e to the minus x squared dx. So there's going to be V equals, the pi can come out, 0 to the natural log of 4, e to the minus 2x. Okay. Right. And so then if we do this, and again, ln of 4, and so this will be pi, and this will be minus 2e to the minus 2x, evaluated from 0 to the natural log of 4. And if you do this, you would end up with 15 pi over 32. Right. And so the next example would be of the washer method. So now I got f of x equals the square root of x, and then g of x equals x squared. And again, if I plot those, I end up having something that looks like this. And then my other one is going to be looking like, looks like this. And again, I need to know the intersection points. And so again, we need to find those first. So square root of x equals x squared. So x is going to equal x to the 4th. So 0 equals x to the 4th minus x. So we can factor an x out. So there'll be x cubed minus 1. So x equals 0. Or x cubed minus 1 equals 0. And so add the 1. So x cubed equals 1. So x equals the cube root of 1, which will be 1. Okay? So we're going to integrate 0 to 1. Okay? So now we're going to have our integral 0 to 1 pi, the black curve on top. So this is going to be the square root of x squared minus x squared dx. And the pi can come up front. So this is going to be x, and then this will be x to the fourth. And so then we want to do our integration, and so pi, it'll be x squared over 2 minus x to the fifth over 5, evaluated from 0 to 1. And so we could then plug this in. So this will be pi, this is going to be 1, so this is going to be 1 squared, which is supposed to be 1, so it'll be 1/2 minus 1/5. And then if I plug in the 0, well, this is going to be 0 squared, which would be 0 over 2 minus 0 over 5. So actually the back part is 0. And so let's see. So this is going to become 5/10 minus 2/10. And we're going to end up with 3/10 pi. Let me make sure I got that right. Uh-oh. Shoot. Stop.